Chapter 5, Time Value of Money. This is Part 2, Subpart 1. So far we've seen that interest can be calculated by simple and compound routes. We've also calculated the future value to which a money invested at a given interest rate will grow. We've calculated the present value of future payments. And we've calculated the present and future value of a series of cash payments. Now next we've also found the interest rate implied by present and future values. Now let's just do a quick recap of what we've seen. We've seen present value times 1 plus rate times time is a future value if we calculate the future value by simple interest. Otherwise, it is present value times 1 plus rate to the power time if we use compound interest. Now, if the cash flows are multiple, the present value can be calculated by sum of cash flow I divided by 1 plus R to the power I for each cash flow. I going from 1 through T or 1 through N, it depends upon how you want to see it. The objective of this particular session is that we must understand what an annuity is, what a perpetuity is, and we'll deduce some present and future values of annuities and perpetuities with examples. So an annuity is a stream of cash flows in which we receive these cash flows for n year. So the present value from the previous presentation, that is Chapter 5 Part 1, is CF1 divided by 1 plus rate to the power 1, CF2 divided by 1 plus rate to the power 2, through CFN divided by 1 plus rate to the power n. To give an example, suppose there's a person. That person has money. There's the same person having the same money. Well, same money. This person wants to buy a car. The price of the car is $20,000. He can pay $8,000 now and the balance after 2 years, or pay $19,000 now. What should he do? So that to buy the car, the person can either pay $8,000 now and the balance after 2 years, that is $12,000 after 2 years, or pay $19,000 now. So essentially we're comparing two different types of cash flows, and these are cash outflows. How do you compare them? So that's why we're confused. Now let's remove the confusion. First of all, we need an interest rate. Assume that the interest rate is 8%. In the first option, the present value is $19,000 because that's what we had to pay up front, and therefore it is the present value of our cash outflows. In the second option, we have to calculate the present value using the cash flow formula, and the rate at the denominator is 8%, 8 over 100 or 0.08. Are we paying something up front? Well, apparently we are. Let's just see how the cash flows look like. We're paying $8,000 upfront, and that will be divided by 1 plus rate to the power 0. Anything to the power 0 is 1. So the present value of 8,000 payable today is 8,000. The second cash flow after 1 year, we're paying nothing, $0. So the present value is 0. The third cash flow, we're paying 12,000, and that's 12,000 divided by 1.08 to the power 2. The present value of that will be 10,288. So if we add the two present values, the present value of today's cash flow, that is at 0, and the present value of the second cash flow, we get a total of 18,288.1. Compare the two present values. Which option is better for us? The second option is better because we're paying lower. The present value of the two payments is lower than the present value of a single payment of 19,000. So we will choose to take the second option. Now let's talk about perpetuities. A perpetuity is a stream of cash flows starting from time t equals 1, 2, 3, and it goes through 5 and so on till some kind of a cash flow n. Oh, it's a perpetuity, so it goes through infinite. And the present value of a perpetuity is the single cash flow. Now we assume for a perpetuity that all these cash flows are the same thing, and that's called the annual cash payment. That's called C. And if the interest rate is R, the present value of that perpetuity means the single value which would compensate me for all these infinite stream of cash flows will be C over R. And to see that, well, let's use the cash flow formula again. The present value is C over 1 plus R. The first cash flow that's available after 1 year, C over 1 plus R whole square, plus C over R 1 plus C over 1 plus R to the power 3, and so on till infinity. Now, let x be equal to 1 over R. So P equals Cx, Cx square, Cx cube, and so on. C times x plus x square plus x cube, and so on. And if we divide both sides by C, then we get P over C equals x plus x squared plus x cubed, and so on to infinity. Then we say P over C minus x equals x squared plus x cubed, and so on to infinity. But wait, that is x times x, which is x squared, plus x times x squared, which is x cubed, x to the power 4, and so on till infinity. So x, x squared, x cubed, etc. is in the parenthesis, and I've taken out x common. But that means this is x plus x squared plus x cubed, and so on till infinity. And that is equal to P over C. So I substitute this x times P over C. So P over C minus x is x times P over C. I'll rearrange that. So P over C equals x times P over C. That's x times P over C. And that minus x goes to the right side, becomes plus x. That's plus x. Next step, I take this x times P over C to the left. So P over C minus P over Cx equals x. And I take out P over C common. I am left with 1 minus x. So P over C times 1 minus x equals x. So P over C 1 minus x equals x. Or P over C is x divided by 1 minus x. In other words, if I substitute x back by 1 plus r, 1 over 1 plus r, 1 minus, so this is 1 over 1 plus r. Remember, x is 1 over 1 plus r. So 1 over 1 plus r, 1 minus 1 over 1 plus r. So this 1 over 1 plus r is x, 1 minus x. So that's what we did to substitute. Simplify it, it becomes 1 over r. So P over C is 1 over r. Our present value P, that C goes to the right on the numerator, C over r. The present value of a perpetuity is the coupon C over r. Now, we're assuming that each cash flow is C, C, C forever in perpetuity. And that's a big assumption, of course. Now, here's an example. We have 2 million now. Can we convert this into perpetuity? In other words, since this sum is available now, it's a present value of a potential perpetuity we can create. So we can say 2000 is C over R. This is 2 million is C over R, and R is 0.08. So 2 million is C over 0.08, or C is 2 million times 0.08, or $160,000. So 2 million now, if the interest rate were 8%, would be equivalent to forever cash flow of $160,000. Conclusion. We've seen that annuity has cash flows for a fixed number of years. So the cash flows in an annuity end at some time. We can find present and future values of an annuity. Perpetuity has cash flows forever. We can also find the present value for perpetuity. It's C over R, the coupon or the cash flow divided by the rate of interest in decimals. That's chapter 5, part 2, subpart 1. Thank you for listening.